All right, good morning, everybody. Good morning, Shane. Looks like we only have a handful of people right now. Probably the same handful that have attempted the homework. So that is what it is, I suppose. So before we get going here too much, let me just talk first about exam two. So you guys should now have access to exam two. I went in, changed the settings. It still needed to be changed. My 126 classes yesterday said they were able to access their exam too, Sean, and so you guys should be able to access it as well. If not, let me know, but you should have access to it. And then exam three. So it's coming up pretty quickly here. So we just have this week and next week of new material, Dominic. And then after that, so 2 weeks from today, will be the review day for exam three. And then 2 weeks from Thursday will be exam three. That's on the 29th. And 30th. Sorry, on the 30th, April 30th. Now, that is the last week of the semester that technically you are supposed to be giving an exam. So typically what will happen that week, and especially that Wednesday and Thursday, is you guys will just be slammed with tests that you need to take. So if that is the case, let's say that you have 3 exams scheduled for the 30th. If it works better with your guys' schedule to take that exam the day after or the day before, or maybe Tuesday, I guess you could do it Tuesday after the review if you want. I would probably not do it before Tuesday. Again, just so that if you have questions, you have a chance to get them answered during the review video rather than, take the test and then the review day is after. So I can do that. I'm able to go on Canvas. Oh, no, actually, you guys will be a web assign, huh? I'll have to figure that out. I'll have to figure that out if I can set the dates for just one student or not. So that might be a problem. I'll look into that. So before we get to that point, I'll let you guys know. And that's really about it as far as sort of administrative stuff. So today we are doing 9.1 and 9.2. This has to do with vectors. So in 9.1, we have this vector, and there's 2 ways that we can format it. We can either use this notation here, where it's our horizontal and our vertical component, and then the magnitude of the vector is the same as the same formula we've been using all semester: Pythagorean theorem, radius, modulus, etc., etc. The vector is just square root of a squared plus b squared. And then we also have this idea of unit vectors, where I is a unit vector to the left or right. If 1 is positive, it's moving it 1 unit to the right. If it's -1, it's moving it 1 unit to the left. And J, the same idea, moving it up 1 unit, moving it down 1 unit. So instead of notating it like this, we can notate it with I's and J's. So for example, 3I plus 2J means 3 units to the right, 2 units up. If there's a minus in there, so 3I minus 2J, it's 3 units to the right, 2 units down. Now, you guys might have discovered some other formulas, either in the book or through the watch it feature. You're like, well, wait a minute, this wasn't in the video. Why did he skip this? And the reason is quite simply because it does not work all the time. It works under given conditions. And I don't want you guys relying on formulas that work for given conditions. I would rather you just draw the vectors where they go and use SOHCAHTOA, opposite over adjacent. Opposite over hypotenuse, adjacent over hypotenuse, etc. If you use that formula, there's a very high likelihood that you will get answers wrong because it doesn't meet the given condition. And so and it has to do with like horizontal components and vertical components, and it's like magnitude of V, cosine something, et cetera, et cetera. Do not use those formulas. So I had a few students email me over the weekend as they were doing the homework. And they're like, oh, well, this is the answer I got. Is this correct? I'm like, well, it's all of them. Where did you get the formula? Well, that's what was on the watch it. Yes. And this is, again, part of the reason that sometimes I think about just shutting down that watch it feature, because they are giving you a formula that does not work all the time. So I don't use it. And that's why it's not on the board. That's why it's not in the video. It used to be in the video. And I went back and re-recorded the video to specifically take it out. Because no matter how much I said, forget that part of the video, a test question came and people went right to that formula and then they got the problem wrong. And I'll tell you now that your exam problem will be one that if you use that formula, you're going to get the problem wrong. So it's up to you. If you want to keep using it, it's your choice, but you are going to get that problem wrong on the exam. The other part of 9.1 is the word problems. And so we can use, and this will probably be concept questions. And so on Canvas, I'll start the concept question thread, start putting some of those ideas that could potentially be concept questions for exam 3 on there. And this is one of them. So if it says in the problem, so let's say we have a jet and wind. So if it says, what's the velocity of the wind? That's just the vector by itself with I's and J's. So if it's blowing due north at 5 miles per hour, it would be 0I if you want a placeholder plus 5J. That's it, just the vector by itself. If it says velocity of the plane or the boat or the salmon or whatever the object is, the velocity relative. That's why I have this underlined, and actually let me box it in red. When you see this word relative to whatever, that means just the vector by itself. So if the jet is flying due east at 500 miles per hour, then it's just the vector of the jet. It has nothing to do with if there's wind or not, just what's the vector of the jet. Keyword here, true velocity. So the before was relative velocity, and that was the vector by itself. If I have true velocity, that means we add 1 and 2. So the jet's flying plus it's getting pushed by the wind. What is its true velocity? That would be the third question. And then 4 is true speed. So it asks, okay, now you have the velocity of the jet. What's its actual true speed? Well, in that case, you find the magnitude, this formula here, of the vector that you generated in step number 3. So is there any question on that, the verbiage? Can you move to the right? So, yep, exactly. Sorry. So number 1, velocity of the wind, the ocean, whatever, that's just that vector by itself. Velocity of the object relative, that's the key word there, relative, it's just the vector by itself. True velocity, when we have the word true there, that means we add these two together, 1 and 2. And when we have true speed, that's the magnitude of the vector that we generated in step number 3. Any questions before I move on to 9.2? So I put both of them on the board today because I want to address them both at the start here. So 9.2 is dot product. So if I have some vector u is a1, b1, and a vector v is a2, b2, then the dot product is a1, the first component. So actually, is everybody done with 9.1? I'm going to erase this because I want to talk about this here. All right. So the dot product is the first number in U times the first number in V plus the second number in U and the second number in V. That's our dot product. It's a scalar. It's not a vector. So if you're asked for the dot product on a test and you give me a vector, it's going to be wrong. Now in the quiz, one of the questions had your A vector is A1, A2, and B was B1, B2. This was the pre-quiz that you guys had. And I had quite a few students saying, you know, well, I put the dot product as A1 and then in the box A2 plus B1 and in the box B2, and it was marking it wrong. Yes, it was marking it wrong. Why? The dot product formula, A1, A2, B1, B2, is because that's what these vectors have as their components. But it's what? It's the first value, A1, times the second value, B1, plus the second component of A2 times the second component of B, B2. Let's see. Yeah, I guess so. I forget what the quiz was now, but whatever it was, you guys were just doing A1, A2 plus B1, B2. It should have been A1, B1 plus A2, B2. So the first components multiplied together, the second components multiplied together. So that's where everybody was kind of going wrong with that guy. And then the last thing for 9.2, and I did not put this in the videos when I made these the first time, so I probably need to re-record this video as well. When I made these videos the first time, I did not include this in, not intentionally, I just missed it in the notes, so I didn't include it. But when we have a question, and there's some that you guys asked about today, angle between vectors, we have a formula for it. The angle between vectors to determine that is cosine of theta, so not theta. The reason cosine is underlined a bunch of times here is because it's cosine of theta is this value, the dot product over the product of the magnitudes. So once you figure out what this is, let's say this is a half, cosine of theta is a half, where, and you always want the angle, you always want theta to be between 0 and 180. So you wouldn't say that the angle is 300 degrees. It'd be, no, it's 60 degrees. So where is cosine equal to a half? That's when theta is equal to 60 degrees. So be careful that it's cosine of theta is that, and not, if you get a half, the answer is not a half. Cosine of theta is half. What is theta? That would be 60 degrees. So went a little long with lecture stuff today, but I just wanted to make sure that some of these concepts are clear. So any questions on any of that? All right, so let's look at some of the problems you guys asked about. So the first one we have from 9.1 is number 7. We have a jet flies due east at 475 miles per hour. And we have a wind that's blowing north at 40 miles per hour. So the first question asks, what is the velocity of the wind? So this is just the wind by itself. So if I draw a sketch for this so I can kind of see what's going on, it's due north, so directly north at 40 miles per hour. So in terms of my I's and J's, well, my I is how much left or right. Well, that's 0. It's not moving left or right at all. So if you want, you don't have to put in 0I, But if you want to write it there so that when you start adding these vectors later, you are adding the correct pieces, that's probably my suggestion. So 0i, and it's going north, so that's upward, so that's plus 40j. Any questions on that? That's just the wind by itself. All right, part B says, what is the velocity of the jet relative to the wind? So relative is our key word there. That means what? Just the jet by itself. So pretend the jet is flying and it's in a vacuum. There's no forces pushing on the jet. Let's draw a sketch for that. And I'm always going to be drawing these sketches in separate grids. Where a lot of people run into trouble is they try to do it all on the same coordinate system, and then they get themselves into trouble. So keep them separate. So the jet is due east at 475 miles per hour. So again, in terms of my I's and J's, I have what? Well, I is left and right. It's going to the right, so that's positive. So this is jet relative to the wind. So 475 to the right, 0 up or down. So if you just have 475i, that's fine. If you want to put in the j component, that's okay as well. Part C asks us, what's the true velocity? So true is all I need to really see here, well, true velocity. And that's what? I just add these two. So add the I pieces and add the J pieces. So I get 475I plus 40J. And again, if you guys need me to stop or you have a question, make sure to hit those exclamation points and I know I'll stop for a minute. D asks us, what's the true speed? So here, the key is speed. That means magnitude of the vector that I just found. So this is square root of 475 squared plus 40 squared. And I believe it asks to round it to the nearest value. Let's see. Yeah, round it to the nearest integer. I believe it ends up 477. Let me confirm. Yeah. So this gives us rounded to the nearest integer, 477 miles per hour. So any questions to that point? And so the last question asks us, what's the actual direction that this plane is flying? Because what is happening then? So now I will draw this on the grid, but I'm going to be using this vector here. Because this is what's really happening with the plane, right? Or the jet. So it's flying to the right, but from where it starts, it doesn't end up directly over on the right because the wind actually pushes it upward. So as the plane's flying, the wind is pushing it upward at 20 miles per hour. So in fact, this plane is going 475 miles to the right every hour. It's going up 40 units every hour. So the plane is actually heading that direction there, not drawn to scale, obviously. But this is what's happening. Every single hour, the plane is moving 475 units to the right, and then the wind is pushing it up 40. And then it moves 475 to the right, and the wind pushes it up 40. So this is the actual direction that it's heading. So how do we figure this out? The problem tells us it wants north some odd degrees east. So how can I figure this out? Well, I can figure out this angle. How? By tangent, right? So if I want to know, okay, what's this angle theta? It's opposite over adjacent. That'll give me theta, but that's not north blank degrees east. Because what? The value that's going in the box is this guy here. So let's call this theta star. And this would be what? This is 90 degrees minus whatever we calculate for our theta. So go ahead and try that. And this, I think it says round to 1 decimal place. Yeah, round to 1 decimal place. So go ahead and try that. Calculate what's your theta using your calculator. Obviously, this could be an exam problem for exam 3 because you guys will have access to your calculators now. So calculate what's your theta. Take that value, subtract it from 90, and that should give you the answer that goes in the box there. Again, if you have any questions on either A through D or this last one, go ahead and type it, and I'll try to answer it as best I can here for you. Shane, did you still need to meet today, or did you want to meet today after this, or at 11:30, I guess? Okay, that's fine. So if anybody else needs to meet today, I'll try to set up a Zoom at noon, and I guess maybe I'll email that out to everybody. So yeah, I'll try to get that set up and then email it to everybody. So that way, if you guys want office hours, then I can do that at noon, I guess. So. And again, when you guys get done with this one, just type done. That way I know you're done, so I don't have to waste your time watching you have me sit here. So. Okay. All right, so again, to find theta, we're going to use tangent. So we have tangent of theta is opposite over adjacent, 40 over 475. So basically, we're doing tangent inverse on your calculator. Make sure you're in degrees. So theta would be tangent inverse of 40 over 475. So theta, one decimal place, is 4.8. So therefore, that's this little angle here. So it's not flying due east. The plane thinks it's going due east, but it's actually going 4.8 degrees upward. So to figure out what the heading is, we subtract this from 90. So we get 85.2 should be your answer for this one. And again, make sure your calculator is in degree mode. Any questions on that? I know I erased most of it, but you guys had the other parts. Okay, so then let's move on. So 9.2. So 9.2, you guys needed number 3. And it was the angle between, so probably now that I give you the formula, it might be a lot easier to do. So I do apologize. I should have given you guys that the other day. I was too worried about the I's and J's with the little buttons. But we have what? U is equal to I plus root 6J. And V is equal to negative root 6I plus J. So first it asks for the dot product. So we do what? The value in front of I, which is 1, times the value in front of I over here, negative root 6. And then we add this to the value in front of J, positive root 6, times the value in front of J there, positive 1. So we get negative root 6 plus root 6, which is what? 0. So the dot product here is 0. So for the second part, the angle between, we have cosine of theta is the dot product 0 over the magnitude of U and the magnitude of V. Well, do I need to calculate the magnitude of U and the magnitude of V? The answer is no. It doesn't matter what these numbers are because it's 0 divided by some number, which is 0. So basically, cosine of theta is equal to 0. So where on the top half of the circle, or where between 0 and 180 degrees, is cosine of theta equal to 0? That's when theta is 90 degrees. So part B for this would then be 90 degrees. Let me see if they want you to put the degree symbol in or not here. Nope. So they already have the degree symbol. So you just need to put 90 in the box. And again, this is a lot easier with that formula. I do apologize for not giving you guys that formula, but now that you have it, it should make your life a lot easier. Any questions on that one, number 3? And then I'll let you guys try number 5 now that you have the formula. So number 5, we have U is equal to 4I plus J, and V is 5I minus 8J. So go ahead and find the dot product for that one. And then find the angle between these two guys. And I believe in this case, you might have to find the magnitudes. I don't think the answer is 90 on this one. So go ahead and try this one. Again, once you get done, just go ahead and type done so I know you're done. While you guys are working on that, I'm going to see if I can get this Zoom set up. Okay. So it looks like I got the Zoom meeting set up, hopefully. I've only done it one other time, so hopefully I don't have too much issues here. Okay. All right, so for this one, again, first thing that it wants is the dot product. So we're multiplying the first values, 4 times 5, plus 1 times -8. So be careful with your pluses and minuses here. So we get what? 20 minus 8, so 12. So the dot product is 12. Because it's not 0, we definitely need to figure out the magnitudes. So magnitude of u is this, we square both of these values and take the square root. So 4 squared plus 1 squared, that's square root of 16 plus 1, so square root of 17. And then for v, we have the square root of 5 squared plus -8 squared. So square root of 25 plus 64 gives us what? Square root of 89. That divide evenly. Oh, okay. So this looks messy. So then our angle between, so we have cosine of theta is the dot product 12 over square root of 17 times square root of 89. So with our radical rules, we can multiply these two. 17 times 89 is 1513. Is this right? Let me check here. These are some horrible numbers. Oh, okay. Yep. So it's right. It's just really terrible numbers. So 12 over the square root of 1513. So divide that out. So what we want then, theta is cosine inverse of this guy. 12 over square root of 1513. So that gives us 1513 square root over times 12. So this is roughly 0.309. Cosine inverse of that gives you that theta is about, I think it says the nearest degree, 72. Does that work for everybody? Did you guys get 72? Is that the answer WebAssign wanted? Can anybody confirm? Is that the right answer for WebAssign? Yes, 72. Okay, thanks, Dominic. All right, so that's that one. Hopefully you don't have anything like that on the test, those really terrible numbers. Again, so I think I told you guys the other day, did I? Maybe I didn't. No, I didn't actually. Because I had my meeting on Friday. So the coordinator has decided to use WebAssign for the final exam, which means I'll be using WebAssign for your guys' exam 3. Yeah, I need to make sure I mention that to the next class too. So we will be doing exam 3 through WebAssign. You know, it shouldn't be too bad for you guys because you've already been doing these assessments all semester, and it's just basically going to be another assessment. One thing is, you know, you guys can use your calculator, so some of the problems might not work out as nicely as maybe some of the in-class exams. But again, they're problems you should be familiar with. So, yeah, I forgot to mention that earlier because I'm losing track of days here, as I'm sure you guys are. So, all right. So then, what time is it? 9:15, 10. All right. So let me give you guys, I guess, your ticket out the door. Oh, so let me I'll email you the Zoom information, but let me give you that information here so you have it. So the meeting ID is 734-942-9640. And then the password is 90, a little o. That's little letter O. And then Z, capital Z, capital P, the number 0, and then capital T. I don't know why they use zeros in the letter O, because it causes a lot of confusion. So that's what you guys, if you got, and this will be at noon, 12 p.m. And we'll call it office hours. So if you guys need extra help, you can log on to that Zoom. Then at least we can talk face to face as well. Yeah, so that's that. All right. So your ticket out the doors for today then. I'll give you these so you guys have plenty of time to work on it. If you have questions, you can ask. So the first one. Oh, so I guess we didn't have an attendance question today. I forgot to do that. So that's okay. We'll skip the attendance question for today. Just your 2 ticket out the doors. You have that a salmon swims north 30 degrees east at 6 miles per hour. And the ocean flows due west at 4 miles per hour. So we have 4 parts of this. Find the speed, find the vector. So express, I want to word this. So write the ocean as a vector. Find the velocity. So the velocity the ocean is, that's what I want to say. Velocity of the ocean as a vector, velocity of the salmon relative to the ocean. Find the true velocity of the salmon. And D, find the true speed of the salmon. And you can leave this as a radical. So you're going to get a radical answer there. Just leave it as a radical. You don't have to use your calculator. Well, you know what? Let's do that. Since we're going to be doing that on the test, let's get you guys used to that. So true speed of the salmon to 2 decimal places. So since you're going to be using calculator on the test, we should do that here. In question 2, you have U is I plus root 3J. V is negative root 3I minus J. So for this one, find the dot product U dot V. Find the angle between the vectors. So give both of those a try. They should take you a little bit, I'm assuming here. Once you get the answer, if you want to put your answer on the comments there, I can tell you if you have it right or wrong. Yeah, if you have questions, feel free to type in the questions as well. So I'm going to email out the Zoom information to everybody. So if you do have a question, you can post it and I'll One for C. For C, true velocity or true speed? So C, you shouldn't have a decimal. The only one you should have a decimal for is part D, and it's not 7.21. Yeah, no problem. But no, the answer is not that. Okay. Yeah, no problem. Just keep working it. So I sent out the email. You guys should have got that. Has all the Zoom, the link, the meeting ID, the password, all of that. Okay. Yeah, so again, everybody else, if you're still working it, if you want to put in your numbers or if you get done and you don't want to type in the numbers, just tell me you're done and I can post answers so at least you'll know. So Stephanie, no. Let's see. So yeah, so don't forget that your I's are your left and right, your J's are your up and down. And then be careful with what it's asking. So if it's velocity relative, that's just the velocity of the salmon by itself. True velocity is the combination of the two. So I think you have B and so your B and C are not correct, but I think you have the concept reversed. So just be careful on that. Thought we had a visitor here. Oh, we do. Cash is here. When we talk at noon, can we go over the answer and how you came up with it? Yeah, we can. Cash, you want to come in and say hi to everybody? Here we go. Careful. So here's Cash. Okay. Back to bed. Go ahead. You're staying in? No, he's gone. Yeah, we can go through some of this stuff, definitely. No. So you guys need to draw the vector where it's headed, north 30 degrees east, and then figure out how much left and right and how much up and down using your SOHCAHTOA. So draw in where the vector is going, like we did with the boat in the heading problems and stuff. Then figure out how much left and right, how much up and down to get to that final spot. And that'll give you your answer for B. And then you'll add A and B to get C. We got 936, okay. So if you guys are struggling with this, if you don't come to office hours, or even if you do, maybe what I'll do is I'll start Thursday's live stream with how to work these out, because you do need to know how to work a problem like this. And unfortunately, it's not really your guys' fault. So WebAssign primarily just has due north, due south, due east, due west type of problems. And then unfortunately, what it does is it makes you think that that's how you always set these up, but it's not. You need to account for the fact that a plane or a fish or whatever, or a boat could be traveling in a direction other than due north, due east, etc. So maybe what I'll do, I'll give you guys these answers. If you're still working it, fine. I'm not trying to kick you off here. So I do want you guys to get these, so feel free to keep working and we'll stay online here. And if you do have them, obviously you're free to go as well, but let me give you the answer. So the ocean is flowing due west. That means it's going to the left, which means we need to have a minus. So this is going to be minus 4i. If you want to put in the placeholder, that's fine. So minus 4i plus 0j. Now the salmon is going north 30 degrees east. So the 30, still the same, has to touch the y-axis. So what I need to figure out is my A and B. So how much left and right, and at a speed of 6. So the length of that side would be 6. So that means the angle inside the triangle is 60 degrees. So using SOHCAHTOA, to get A, I can use cosine, A over hypotenuse, and then B is sine, opposite over hypotenuse. So for the vector for the salmon, you would end up with 3i plus 3 root 3j. You're not going to get nice numbers for part B. Part C, we add these two together. So you get minus I plus 3 root 3j. And then when you find the true speed, it's the magnitude of this vector here, which should end up to give you square root of 28, which to 2 decimal places is 5.29. So that should be your answer for that guy. And for number 2, the dot product is -2 square root of 3. And so the angle between them, when you figure out magnitude of u and magnitude of v, cosine gives you that. So where is cosine equal to that value? It means the angle between them is 150 degrees. So again, that's the answers there. You guys need to be able to figure out these kind of problems. So if you weren't able to get it, try to go back. And if nothing else, we can go through this at the start of Thursday's class to make sure that you guys understand how to do both of these problems. But again, if you are still working it, you still have a few minutes here, 3-4 minutes. I'll hang on here onto the video. If not, if you guys are free at noon, feel free to come to the Zoom office hours. You should have all that information now. I emailed that out. Otherwise, you guys have a good afternoon, good night. We'll only have they limit the time, so we'll have till 12:30. But yeah, we'll get through as much as you want to get through. So. All right, so I'm gonna shut down the stream here. If you guys do have other questions, feel free to email, or again, join the Zoom hours. And we'll see you guys later. Have a good day.